Hello and welcome. This video is about building a simple trading strategy using Python. The strategy we will implement is the so-called momentum strategy. The strategy is buying and selling stocks based on their past performance. Let us take a look at what we are going to do in more detail. So first we gotta pick a stock universe. In our case we are picking the Dow Jones Industrial Average, which is, to be honest, not the best index to pick for the strategy, but is perfect considering the number of constituents. So we have a lucid number of 30 companies here. The next step is to take a look at the performance of every single stock on this index over the last year. More specifically, we will skip the most recent month, so we are ending up having 11 past months. If you are interested why we are skipping this most recent month, just drop me a comment or check the video description. After that, we are buying the best performers over this past period and sell the worst performers. This portfolio we are holding for 1 month. Let us take a look at what do we need to do in Python to implement this strategy. So first we need to get all stock prices from the Dow Jones. After that we are measuring the performance of over the last 12 months, skipping the most recent month. Then we are using quintiles to define winners and losers. A quintile is just slicing the data into equal sized buckets based on the performance. So if we have 30 stocks, as in our case, we would get 30 divided by 5 because of quintiles, equals 6 stocks in every quintile. So the best performers are in quintile 4, these are the winners, and the worst performers are in quintile 0, these are the losers. In the end, we are calculating the strategy return and compare this return to the benchmark, so the Dow Jones Industrial Average performance. Okay, let us code that strategy via Python. So first of all, we need some modules. That is the pandas data reader to get stock prices from the internet. We need pandas for data handling. We need the datetime module to create datetime objects. And we need this relative delta to go back in time. You will see in some minutes what this is about. So for a better overview, let's actually describe our steps here. So first of all, we want to get ticker symbols for the stocks contained in the Dow Jones Industrial Average. So let's write down get ticker symbols for the stocks contained in DJI here for Dow Jones Industrial Average. And well, you can do web scraping stuff to get those ticker symbols, but I'm going a very easy way here. So I'm just clicking on Yahoo Finance here, search for the Dow Jones Industrial Average, click on that, and then click on components here. And what I'm getting now is a table, an HTML table containing what I need. So that is those ticker symbols here. So I'm just reading in that table. So pandas has a function for that. So we are using pd.read_html. And now we just have to provide this URL containing this table. So we are using this one here, copy pasting that inside this parentheses here, and let's execute that to see what is happening. And as you see, we are getting a list containing this table here, right? You see that taking a look at those squared brackets here. So let's access this list by just using zero index, because we only have one element in this list here, and that is this table. So we are just using a zero indexing here, and as you see, now we are getting a data frame. So pretty straightforward, right? So let's actually store that in a variable. We are just naming that table. And now we are accessing this symbol column and transform that to a list. And we can do that by just using table.symbol. That is the name of this column here. And we're just using toList. That is a function transforming a column to a list. And we are storing that in a variable which we are calling tickers. And after that, we are printing out this list. So as you see, we are getting a list containing all ticker symbols for the Dow Jones Industrial Average. Okay, now the next step is to get prices for all those stocks. So let's type that down, get prices for the DJI components. And now we have to define a time horizon. So let's define start as dt.datetime. So we are just creating a datetime object here and provide the year, month, and day as the argument. So let's start in 2018 we're just taking the end of January here, and as the end date we are again using DT datetime, and we are taking the end of January in 2020. So you can take other dates here, but this is just for an example. But be sure that you are covering 1 year, as our strategy is based on the past year's performance as explained. Okay? Now we can perform our online requests here. So we are using reader. So reader is just the pandas data reader as we defined above here. So we are using reader.get_data_Yahoo and provide tickers. Tickers are again 30 components of the Dow Jones. And we are also providing start and end here. And we are just interested in the adjusted close price of those assets. Okay? And we are storing this request in a data frame which we are just calling df. So let's execute that. And now this will take some seconds because we are getting like prices for 30 stocks here over 2 years. So this is taking some time. So let's go through this waiting time together. Oh, actually it doesn't take that much time. So let's print that out. And as you see, we are getting the assets as the columns of this data frame. So for example, BA is Boeing or 3M or IBM or JP Morgan and many more. And also we are getting the index of this data frame, which are the trading days. So starting at the end of January 2018 until the end of January 2020. The next step is to calculate monthly returns, and I've covered that in many other videos on my channel, so I'm not going much into detail here. What we are doing is to get daily returns first, and then we are accumulating them on a monthly base. So let's do that, but first of all we are writing what we are doing. So we are calculate monthly returns by accumulating daily returns. So let's define a variable here, monthly returns. And first of all, we have to get daily returns, and this is easily done by just using df, and then we're using pct_change here. And now we have to resample this data frame and get that on a monthly base by using the keyword m here. And now we are aggregating those returns by using a lambda function x. Then we are taking x plus 1, take the product out of that, and then we are subtracting the 1 again. So this is just accumulating those daily returns to a monthly base. So let's print that out, that you are seeing what's going on here. Now we're getting this data frame, and as you see here, we are getting monthly returns, right? January, February, March, and so on and so forth. I don't know why it's so slow right now. But nevertheless, as you see, we are getting monthly returns. The next step is to calculate the returns over the last 11 months. Let's type that down. Calculate returns over the past 11 months. 11 months because, as explained in the introduction, we are taking the past 12 months and skip the most recent month. So we are ending up with 11 months. Therefore, we actually need to import numpy. I forgot that in the beginning, sorry for that. So let's import numpy as np here. And now we are defining a variable which we are calling past 11 for the past 11 month returns. And we are using our monthly returns, add a 1 to that, use the rolling function and provide 11 months as the argument. And now we are just applying a accumulating function. So we are using np.product for that, and afterwards we are subtracting a 1 here. So let's print that out to see what is actually going on here. As you see, we are getting first of all a data frame containing not a number values, and that is because we just don't have the prior 11-month returns for those values. So makes sense, the first 10 rows contain not a number value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows without any values here. And the 11th row is containing a value, as this is just the cumulative return over the past 11 months here. Same logic holds for the subsequent rows. So Every single row is containing the cumulative returns over the past 11 months here, okay? So yeah, what is our next step? Our next step is to actually define our portfolio formation date. The formation date on the one hand is just the date where we are buying the winner stocks and short selling the loser stocks, and on the other hand our reference point for past performance measurement. So let us set our formation date here. Let's just define that as formation, and we're just taking the end of December 2019 here. So let's define dt date time 2019 December 31. Now we want to specify the end of measurement date, which is just 1 month before the formation date, as we want to skip the most recent month. So let us set, let's just call that end underscore measurement. And we are just subtracting 1 month from the formation date here. And we can do that by using the relative delta function. So we are just using relative delta, which we imported at the very beginning, and provide 1 month here in parentheses. So let's execute that and let's print out those variables to see what we got. So our formation date is the end of December 2019 and our end of measurement date is November 2019. Totally makes sense, right? With that, we can get the past 12-month performance skipping the most recent month for our reference date, so our formation date. So let us define that as, let's just call that red 12. And now we are using the past 11 data frame. So we are just using past underscore 11 and use the log function to find the date and measurement. So November 2019. Let us execute that and actually print that out, of course. And what you are seeing now is the past 12-month performance skipping the most recent month for our formation date, end of December 2019. As this is a series right now, I want to transform this series to a data frame to make it possible adding columns to that. I can easily achieve that by just resetting the index, so I can use .reset underscore index, and as you see now I'm getting a data frame out of that. So we can just reassign red 12 to the red 12 with the resetted index, and we got our data frame here. Okay? Now we want to assess which of those stocks are the winners and which are the losers. Therefore, we are using quantiles. More specifically, we are using quintiles. Quintiles are used to divide a set of values of a distribution, in our case the returns, into 5 equal parts. So if we have 30 stocks, as in our case, we are getting 5 quintiles containing 6 stocks in each quintile. The highest quintile is quintile number 4, these are our winners. And the lowest quintile is quintile number 0, these are our losers. Pandas has a function to do that for us, the qcut function. So let us add a column to this data frame by using red 12 and then just define the column as quintile and define that as pd.qcut and first provide the column containing the returns as the first argument. So we need the second column of this data frame. So I'm just using the ilog function here. So I'm providing .ilog and take all rows, and I'm only interested in the second column here. So remember, Python indexing starts at 0, so this is the 0th column and this is the first column here. So this is right like so. Now the second argument is to define the quantile. In our case, we are using quintiles, so we are defining 5 here. If you want to pick, for example, deciles, you can choose 10 here. The third argument is to set labels to false, which is just preventing us for getting the actual ranges for every single bucket. You can set that to true and you will understand what is happening. In case you don't, just drop me a comment. So let's execute that and print out this data frame again. And as you see here, now we have this data frame, and for each asset we have a quintile where the return is sorted to. So let's take an example. So Visa V has a pretty high return and is in the highest quintile. So Visa is a winner here. Or let us take 3M, has a pretty low return or even negative return of roughly 8% and is in the losers bucket here. Okay? So let us finally define our winners and losers. Therefore, we are setting winners to, and now we are just using Boolean indexing here. So we are just setting that to red_12.quintile. So we are accessing this column here, and we are just setting that to quintile number 4. These are our winners. And the same logic for our losers. We're just using red12 and again use Boolean indexing to get those stocks which are in quintile 0. So let's execute that and print out our winners here. And these are our winners, and print out our losers also. These are our losers. So we should buy those stocks here and hold them for 1 month. And we should short sell those stocks here and hold this short sell position for 1 month. This is our strategy. Now let us check if this strategy would have been profitable. We already have everything what we need for that, as we just need the return in January, as we are holding this portfolio just for 1 month. So we can just scan the monthly return data frame for the winner and loser symbols for January. Therefore, let us define winner return as monthly return. So this is our monthly return data frame again, and we're using the log function, and take a look at formation and now plus relative delta and take 1 month here. And we are now providing for the columns, we are using df.columns is in, and then we are just providing the winners.symbols here. So again, we are just scanning the monthly return data frame for January, and we are only looking for the winners in this data frame. So let's execute that. Oh no, let's define loser return as well. So we are using loser red here, and let's just copy paste this whole syntax here and do the right amendments. So we are using loser return here and use the losers symbols here. So we got that. Let's execute that and let's take a look at the winner returns here. Winner return. And as you see, we are getting the returns for the January here, and also we are getting the loser returns for the January as well. And now we are just assuming that we are investing equal weighted. So of course you can invest value weighted as well. So you can, for example, overweight certain stocks, but we are just assumed that we are equal weighting all those stocks in our portfolio. So let's calculate our momentum profit here. So let's define that as momentum profit. And therefore we are just taking the mean out of those assets return here. So we are just getting winner return dot mean minus loser return dot mean here. Why we are subtracting that here? So we have a short position here, so we are making money when the stocks are falling. So this is why we are subtracting here. And if we're executing that and print out our momentum profit, we are getting a return of 8.5 or 8.6%, which is actually pretty nice, but we can not yet assess if this is a good profit. So let's check how the Dow Jones has performed in January to check or to benchmark our strategy. So therefore we are just defining DJI here, take the reader, the pandas data reader again, get data Yahoo here, provide the ticker symbol for the Dow Jones, which is just the head, and then DJI here. And we are taking start and end as well here. We are interested in the adjusted close price. And we are interested in the percentage change here. And also we have to resample this data frame to a monthly base, and we need the cumulative returns here. So we are again aggregating using the lambda function x, and then we are taking the product of x plus 1, and afterwards we are subtracting 1. So again, this is just getting the cumulative returns. So we have already done that, so I'm just typing that down here. So let's execute that and print out the performance of the Dow Jones, and we got the January performance here, and this is just minus 0.9%. So we have clearly outperformed the Dow Jones Industrial Average by buying the winners over the last 12 months, skipping the most recent month, and selling the losers. Since we had to go through a lot of steps, I thought it would make sense to do a quick repetition through all those steps again. So first we have imported all those modules, then we were getting ticker symbols and defined the time horizon to perform the online stock price data request. Then we were getting monthly returns out of that and accumulating them with a window of 11 months. Then we were setting the portfolio formation date and subtract 1 month to account for the skipping month. And finally, we got the past 12 months, skipping the most recent month, which we were storing in red 12. Then we were creating a data frame out of this series to add columns to that. And we added a column containing the quintiles using the qcut function. And then we were getting winners and losers by the highest and lowest quintile. Let's zoom out a bit. Then we were calculating the winner and loser return by finding the January return of the winner and loser symbols. And then finally we were calculating the profit of the momentum strategy. Afterwards, we were calculating the profit of the benchmark, that is the Dow Jones Industrial Average performance. And as a direct comparison, we have a momentum profit of roughly 8.6%, while the Dow Jones Industrial Average performance for January was minus 0.9%. Yeah, and that's it for building a momentum strategy using Python. So of course we can extend the strategy to a larger index like the S&P 500, and also could backtest the strategy long term to see if momentum strategies are working in general. So if you are interested in this kind of videos, please drop me a comment, like this video and subscribe to the channel, that I can get feedback which kind of stuff is helping you out. That being said, I thank you very much for watching and looking forward to seeing the upcoming videos. See you next time. Bye bye.